Nice. So okay, so maybe we should start with this then. Here was the challenge that I had suggested we work on today. And it's just a contract, and you give it an integer n and a process p, and the goal is that it will just run n copies of that process. And Jim already solved it before we got here today. So do you want to tell us about the solution?
Yeah, well, basically, the premise here is that although this executes sequentially, it's really an arbitrary sequence
Yeah.
of putting things in par. And basically, I just, you call it with n repetitions of a process. In this case, I write the sample, I write the string par to standard out.
Yeah. So this is your P, right? That's what we're going to try to replicate 5 times.
Right.
Yeah.
And then I just, if the number is greater than 0, I call it recursively.
Yeah. That's the recursive call.
With n minus 1.
Totally.
And then in par, I execute P.
Yeah, nice. So we basically spawn one of them here, and then we make the recursive call to spawn n minus 1 more of them.
Right, but that's done in par, so it's done at the same time. Right. In essence, all the P's, if the P is long running, obviously, they're going to be running concurrently, right?
Totally. Yep, totally. That's right. And and the way to think of this is like however long P takes, there's going to be some quick little, O of n, in this case, O of 5, like iterations to spawn them, and then they'll all be running totally concurrently. Yeah.
And this is because this is asynchronous, right? Yeah. All the sends are asynchronous, and
these sends, you mean?
No, this recursive sends.
This one here.
Yeah. But also this one. But we don't care about this long running. We only care about this one that creates another replicas, right?
Yeah, so certainly it's true that that's asynchronous. Why are you saying that's important?
I mean, we are using this property of asynchronous to create this parallelism. This is like, I think about it.
Yeah, I see.
I mean, we must have some kind of ability to just asynchronously spawn processes and make it parallel.
Yeah, but I think if this were PyCalc, we could put a continuation on here too. Well, I don't know what it would be. I guess it would be nil, but it might still work. Well, maybe that's what makes it work when it's asynchronous, I guess.
Yeah, I'm thinking of that we don't have any continuation. We just send it and forget it.
I just realized it's interesting in PyCalculus, even though it's synchronous and you can have the continuations on your sends, there's still only information travels one way, right? The message goes from the send to the receive. It's not sort of this like bi-directional swapping of information.
Bi-directional, you mean? I'm thinking of functions, but you don't think about functions.
Yeah, no, I do. Well, yeah, I guess we're ready to get a text editor at this point. Wait, is that going to open? I wanted a new window. Oh, there we go. Yeah, I got it. Oh, sometimes my stuff is super slow when I'm on Zoom. Okay. Oh, now we got 2 of them. There we go.
Yeah, I experienced that also.
Yeah.
Very
so, well, imagine we have this. Like, imagine if this were PyCalculus and we did like new x, and then we do like xbang 5, and then the continuation is like, I mean, I'm kind of making this up as we go, but and like mixing syntax in something. and then in parallel, we can do something like for, you know, y. I gotta close that. That's gonna drive me crazy. For y from x, then whatever we're going to do here. Y. Okay. So it's what I was thinking is interesting is like, you know, it's totally synchronous in this case because it basically means like we're going to send this message and then run this continuation. But it's unique because the 5 from the send makes it into the continuation of the receive, like it gets bound, but there's no, like, nothing from down here gets passed into up here.
Yeah. And then can you give some examples where this is transferred?
Where, say that one more time?
Do you have an example where that you have this transfer in other way?
No, I don't. I just now realized that PyCalc doesn't do that. I just was noticing.
And in rholang, but in rholang you say you can do this.
Oh no, no, I'm not saying you can do it. I'm just observing that in none of these calculi. Oh. I noticed one where you have this additional expressivity, or maybe it's not even additional. Maybe we can code it, but like we don't have the semantics where like you know, two things come together and they both exchange information. Yeah, I don't have any examples of it. But
yeah,
but can we have
that? We have two ideas of a channel. One bidirectional and one unidirectional. And the general case is that we can address channels in both contexts, but they have to be part of the namespace in both contexts.
Okay. Yeah.
Can we send? I mean, we can send some channel to, so the receiver can like send us back something. If we
yeah, totally,
receive.
totally. Like is this what you're thinking about?
Oh yeah.
And then we can, yeah, this totally works.
Right.
Oh yeah. Oh, that's how you encode it.
Is this?
Oh well, here, man, I wish I knew how to make those pop-up messages stop coming up, but I just realized I don't. But okay, here's I think maybe why it isn't quite so. Like, let's see, and then in here you're saying like, let's see. Let me make sure I understand first. Let's try to make this like, well, here, I'll name them like this: X to Y and Y to X. So we send this message and we get, and so, yeah, so what I'm gonna send is this one, Y to X, and they're gonna accept it. And some value, and then on Y to X they'll send that, and then, you know, maybe we could like, oh boy, the val or something like that. Is this kind of what you were thinking of? Oh, I didn't finish.
Yeah.
Did I? We got a for val from Y to X. So here's, oh, wow, well, this should be, yeah, they've got to send some actual value. Okay. Yeah, so here's my only thought now. It's not an atomic operation when you do it this way. Like, we could have this message come down here, but then if there just happened to be something else that was listening, like for val from Y to X, you know, then whatever. Like this one could steal the message.
Oh, I see.
Yeah, that's not even what I intended to really be talking about, but that turned out to be kind of an interesting thing. Oh, you know what you could do though? You could the person who sent up here could like create some unforgeable name and only send it down here and then require that like as part of the pattern, instead of accepting this, they have to also have the secret or the shared secret or whatever. And it would have to be the same one.
This is similar to your example with Adam and Eve.
Yeah.
Right? I didn't have time to think about it. I remember that I made a pull request to your poster.
Yeah, yeah.
This is interesting.
Mismatched here, but because this should be tabbed in. There we go. Now I'm confused. So I don't know exactly what would go down here, but that might. Well, I guess if we're recording, it might be worth solving this. So, okay. Goal. Two processes have bi-directional communication where the initiator receives an authenticated response from the Bob.
And then put a note, this is not a rholang, right? This is like...
Oh, I forgot this isn't rholang. We're never even able to run it. Darn it.
And I'm thinking, can we change it to, and do it in rholang?
Yeah, that would be fun.
We can use some another channel, right? To simulate this, like a...
We've got to get rid of that continuation, right?
Yeah, but we will do this continuation on some receiving channel that we will send, right?
Yeah, talk me through it. It sounds like a good idea.
Yeah, I mean, I'm thinking the same thing that you already done here.
Just add the continuation as an argument.
Tell me a little more. What line number are you thinking about?
10.
10. Okay.
Jim, do you thinking about like the argument is a 4?
It's a process.
It's a process, input process.
Input process, a 4, a receive.
Yeah.
Like right here as an argument, you mean?
Yeah, no, I was thinking that the continuation would be run in the receiver. I thought that's what you were saying.
Oh, like send, like whatever the continuation was gonna be, actually send it down here.
Yeah.
That's
I think this example that you and Mike was chatting about.
Yeah.
Can you do something like that?
Yeah. So walk me through it now.
Well, I don't know.
Oh, okay.
But you know what I'm talking about. This when you send the 4, and this is like very interesting.
Yeah.
Now, can't you just put the whole continuation in as the third argument? They're the same.
Yeah. Like that, right?
Yeah.
Let me see if I can make that a little less hard to read.
Can you do this with the new?
Oh yeah, totally. Shoot. You can put a new in there, no problem.
Okay. This is okay. Mm.
Oh, I mean, I don't know. I guess we can find out. I assumed it would be okay. The question, I guess, is like, when does that new name actually get instantiated?
Well, it'll be instantiated when we run it. Of course we can do it. The new is legal.
Yeah, that's what I was thinking originally too. Okay. Yeah. So we send this whole thing down here, right? okay, so our goal was that two processes have bidirectional communication. So basically, here's what we want to do. Alice chooses a secret number and Bob chooses a secret number, and they swap them. And then Alice says, I know that Bob's secret number was blank, or something like that. So we can, I'm just kind of guessing here. So interrupt me as soon as.
I don't even think you need a secret in this case. Because
Oh yeah, I mean, I understand that you may not need one, but we want to demonstrate definitely that we've achieved the goal at least, right? So we have to show that they've communicated.
right.
Yeah. Okay. So Alice to Bob says, well, okay. So we also have to kind of consider, like, what do they share these two names already, or should we assume that they only share one?
I think I'm thinking in terms of, the inbox procedure for the Colab community. Okay.
Okay. Yeah. I definitely don't know all that context, but that sounds relevant and helpful.
Okay. So we publish at least within the community, we'll publish our inbox address as a write-only address. Contract.
Yeah.
Contract.
Yeah.
So that's similar, except this is anyone to Bob.
Mm-hmm. Yeah. Yeah. So the original concept was to try to encode a calculus where two different deploys could come together and swap information. So it almost seems like they should only have like one channel in common, because that's how a COM event would normally work. I think, right? Like I would have done when we still had it with a continuation on the send, like they only shared a single channel. Well,
Right.
okay. Anyway.
I'm not sure that.
Yeah. Go ahead.
No, I'm saying that I'm not sure that I'm following you. So.
Oh yeah. Okay. So here's what I was thinking. So we've got, like, although I'm going to write them in one file, I was sort of thinking of, like, well, okay, here's a basic comment, right? We just do like x bang for, and then for, whatever, like from x, then whatever. So what I wanted to simulate was basically, like, imagine someone deploys two things, a send and a receive. Only, I guess in this new calculus that I'm inventing, there's only one kind of thing to send, or to deploy, right? It would be like a combined send receive. It would have a channel that you send over. So, okay, each process, here's our calculus. P is either nil or, we've got to make up the syntax now, I guess, right? X, or some send, which is parametric in, of channel that we're going to do, a message that we're going to send, and then a continuation, or like bindings continuation. So I don't know if this is making total sense. So there's like there's the stopped process. Oh, and then there's also par, which is parametric in two processes. So we can par things together. We can have the do nothing process, and then we can have this thing that I'm calling it a send, but it's really like a send and a receive, right? Like you choose some channel, you send a message on that channel, like to the other process that you're comming with. At the same time, you receive a message which you sub in for some binding, and then run the continuation. Yeah, go ahead.
The send you're thinking of is like everything that you need for a COM event, but you don't have everything. right?
Yeah, oh yeah, that's interesting. It is basically everything you would need for a whole COM event. But the difference is it's not going to like self-pollinate here. Like this message will not will not like be subbed in for these same bindings in this continuation. But when we have another one of them, when we have two of them in parallel, then if they're on the same channel, then they can COM. And the message from one subs into the continuation from the other, which is, so far I've just described rholang, but then I say, and vice versa. Like the message from the other subs into the continuation from the first one.
Mm-hmm.
So I guess I was wondering if that could be simulated.
Okay, I think I understand.
So like,
So
yeah, go ahead.
In a sense, you want to send for each send, you will always have argument to receive.
Yeah.
Is this similar to what you were discussing with Mike?
I don't know. That's a good question.
You know,
That's a good question.
This is a transaction. It's an exchange. It's like
yeah.
It's like with quantum.
Yeah, exactly. Like atomic. Yeah.
Right.
Yeah. So like if we made up some syntax, let me just here's an example reduction. I don't know if this calculus would even be useful for anything, but for example, we might have a program that looks like this. New x in, so I guess apparently new p in p. There's also that, apparently. Or new of p and p. Or new, I don't know. We can do this new thing. I'm not sure how to say that yet. So here's the example program. We're going to send 4, and we're going to receive x. Let me call this channel to make it more obvious that that's the channel. And then we're going to have some continuation. There's print statements in this language apparently.
So okay. This is like a short version of 4. When you just when you just put the asterisk.
Yeah.
Right. This is like a 4.
Like an FOR, you mean?
As an input. Yeah.
Yeah.
This is like a question mark. This is like an input, right?
Yeah.
Exactly.
We're sending the message for. We're receiving something that we're going to bind to the name X, and then we're going to run this continuation. Exactly.
I remember languages that use that question mark.
Yeah, I stole it from some PyCalculus stuff I had seen at some point. So here's the other half. By itself, this doesn't do anything. Just like a single send or a single receive or whatever, it won't do anything. But here's the other one. 5, and we'll receive Y. And then we'll do whatever. Print Y is 5. Y is Y. So my thought is that this would reduce to 2 print statements that say X is 5, Y is 4.
Oh, I see.
Because they sort of come together and flip-flop.
Okay, let's write it in rholang.
Yeah, right. So let's write it in rholang. So that's right. That's what I wanted to achieve. So how do we write it in rholang? So we have to assume that they have a channel in common if we want to have them communicate over this same thing.
But this common channel, we need like 2 common channels. One for the first send and other for returning channel. And then this returning channel can be created inside the receiver.
The return channel can be created inside the receiver. Yeah, okay.
and send it back.
And send it
But
back over the same original channel.
over this common channel.
Over the common, yeah, right.
Right.
Okay. So I'm gonna start us over maybe, or Jim, do you feel like this is nearly ready to go? Or we're gonna, so okay, so in the example we send 4. So we're definitely gonna need to send a 4 in there. And then, sorry, a 4. And then what? I'm not sure what else happens. But
Can we just send this common channel?
Send the common channel. Oh, that's what I meant. That's what I meant to do. Like that?
No. I was thinking that we want to send the common channel to this receiver.
The common channel is the way that we know the receiver. It's the only thing. So like down here, the only thing that in common is chan, right?
Okay.
So
Okay. Yeah, I was thinking another channel, like a return.
Yeah, like a new one, right? Okay, new like. Should I just call it return?
Yeah.
Yeah.
But now, can we do it atomically?
Yeah. Right. Oh yeah, because in this case we like Bob
Yeah,
can
but
take the number 4, but we wouldn't get anything in return.
but we can expect something on the return channel, and what we receive on the return channel, it will be like the return value.
That's right. That's right.
In parallel with a common channel.
Yeah, in parallel with the Wait, say that again.
Inside the new return, we can
return. Yep.
Yeah.
I think
We can have a 4 that waits on return.
Oh yeah, right. Okay. Or so the only problem here is this is going to require, maybe this is okay. I think this is okay. I was going to say it's going to require Bob to comply and like actually give us an answer back. So ideally, maybe this is the whole thing about behavioral types. What we'd like is to only make sure this thing only comms with other things that are going to follow the interface the same way. Oh yeah, maybe this is similar to that example.
But this is like a simpler example, right? In your case, in your case, you're matching on this 4 on this like for term that is sent to receiver.
This 4 or this 4?
Like input, yeah. This 4 expression.
Yeah. That's an easy thing to solve. Yeah. So this one, right? So for this.
Yeah, for processor. I don't know how to say.
Yeah. Yeah. No. I gotcha. So I almost was thinking, like, what if I don't know if this is a good idea, but here's just a thought. What if we do like contract, like make whatever, I don't know what we're gonna call this, like send, receive, hybrid, one of these things that we're making. And the way that
this is exactly what I've been thinking. I mean, it's we're making an interactive channel or an contract interaction, I would call it.
Yeah, okay. And so when we do one of these things, we have to give it, well, we already said we give it a channel, a message.
You just want to return the capability.
I think we might be designing different things.
Well, if it returns a listen capability, then Bob can write it and Alice can read it or whatever.
Yeah.
But that first step is necessary to create that listening. There has to be a listening created first before Alice has to create a listening before Bob can send her anything. So, that's where the contract should just return a capability or a right capability to her listening.
Okay. So my one thought that I had was if we somehow like use this contract where we send in, like if I wanted to deploy one of these things with a, particular send and a particular, like this part kind of makes up the receive, then maybe we can just call it into a contract and this is going to somehow act like an ADT, like this is our data type and we can sort of enforce how they interact with one another. But then I wasn't totally sure. We would almost have to like, I'm thinking, I'm having this weird idea about like a map of channel names to like unforgeable names that were created inside this contract specifically, or something like. It's getting a little abstract. I'm wondering if we should. I'm wondering what you guys are in the mood for.
Oh, I am.
You are?
Yeah, definitely.
Oh yeah. Okay. All right. Cool. So, okay. So what if we just do like name map channel and we send an empty map? And then, okay, so we're going to need new name map channel and make send receive hybrid. Okay, so whenever we want to make a new one of these things, we're going to, first of all, grab the map. And then once we have the map, we're gonna I don't know if this is gonna make sense or not. Somehow I was thinking that like there would just naturally be I don't know exactly what I was thinking. Somehow, I guess basically somehow we need to make pairs of sends and receives and then marry them up when another one with the same channel comes in.
Can you say it again?
Yeah. So we need to make we need to keep track of things like this. This is our like basic object that we're working on. It has it has 4 pieces, kind of 3 pieces. It has like the channel, a send on that channel, and then a receive with a continuation on that channel. And so I was trying to think of a way that we can wrap that up in like an abstract data type so that it basically has, those couple of properties, the message you're going to send and the receive. And then somehow we just need to we need to facilitate the comms basically, right? We need to say like, okay, we have 2 of them now. They're both on the same channel, have at it, like go reduce each other, reduce with one another.
I'm trying to understand how the context and holes are like.
Oh.
How to do it in Haskell and also how they are working. And can you think about this in terms of that you have a rholang term that have some holes, and when you supply the name or the process, you can also, this can be the name of the process, and when you supply it, then something will happen. Maybe some calm event will happen.
Yeah.
Do you think this is like, can this be seen like this?
Yeah, maybe. So you're thinking about like if there's some process with a hole in it, right? Some context.
Yeah, and
Yeah. Go ahead. Say it one more time. So there's some context.
that have a hole,
Yeah.
and I'm not sure when Greg is explaining this. You have a hole, but is this hole like a free variable?
Yeah. Oh, yeah. That's right. That's a good.
I'm,
I didn't realize that. I hadn't phrased it that way, but that's a good question that I think is maybe something I haven't understood totally. Yeah, maybe those are basically like just free variables.
I mean, when you write a new something and then you have a body,
Mm-hmm.
this new is a whole, because you're saying I don't know what is the new now. I'm just saying new name and this will be supplied later. So my question is this the same really? Is this the whole or?
New. You're talking about new now, right? Like this one.
Yeah, yeah.
Is it a
Because
whole?
yeah, these variables, these new names that you are creating,
Yeah.
you don't have it. You're saying these are my holes in this expression, and you can put any name you want in this place.
Any name you want.
Or but not any name, but anything that can be described as name. Like this can be like a more richer structure, not only.
Yeah. But I don't think it's up to like the user to then decide what goes. Like when you restrict it with new, it's guaranteed to be unique, though. I think is important too, right?
I mean, it's not unique or when you write it in a source file. I mean, you can copy paste
characters. It doesn't have to be unique. That's right.
Yeah, and I mean, you can copy paste it like a code.
Yeah.
You can duplicate it, and this will be different variables, different names, right? This is like a whole because you can put different names and
I see what you mean. Yeah, totally. Yeah.
But they must be the same types.
The same types. Okay.
Yeah.
Yeah.
And this is exactly what you are saying, right? That
that they have
not
types.
Yeah. You cannot like send everything you want. You have this abstract type, abstract data type. Only this type fit.
Oh yeah, exactly. Yes, that's exactly what I'm saying. Yeah, right. So I don't want one of these kinds of ones that we're making to have like a partial com with a regular old rholang term that is never going to answer back because that's just not what it was set up to do or something like that. Oh, I don't know. Were we talking about the same thing?
Yeah, but I didn't exactly understand what you're saying.
Well, yeah, I guess like the goal was, maybe it's sort of formed as we've, been chatting, but I was thinking we're going to try to simulate like this kind of calculus in rholang to see if it can be done. And if it can, that's significant because it tells us we don't gain any more expression in this new calculus. And so like one way to kind of do it in practice is this thing where Alice contacts Bob, sends a message and the continuation, and then Bob will, run his continuation. And part of it is to run Alice's on her behalf. And that'll work fine as long as as long as the thing that receives Alice's send is actually a thing that will then go ahead and run her send. And so like the challenging part is to make it work so that you're guaranteed that like the thing that Alice sends doesn't get received by just some regular old rholang receive that's just going to like do nil as the continuation or something like that.
Mm.
Yeah. But I think what you were saying sounded relevant there, because like the idea is we have to make sure that, whenever we create two of these things, we don't want them to have comm events unless it's on the same channel.
I see.
Okay. Yeah. Anyway, I guess, I was thinking, I'm torn between, should we come up first with something like basic that works, or like explore a higher level idea? I was thinking maybe like an idea that would take some coding, but maybe would work, was something where we have like the channels that we pass in are, like fake channels, like they're just strings or something, but we're pretending like they're channels, like in the PyCalc sense, where like anyone can write down, these public channels. And then it was like, it was going to be a mapping from those kinds of channels to some channels that were controlled specifically by this contract here, that were like made new every time you oh, wait a second. Yeah, maybe that's it. So maybe this contract just has some like identity. I'm just really thinking out loud here. Like I don't have a fully baked idea. New like authority secret. So somehow this contract, like when I call it up, I'm thinking of this almost as like a constructor. Constructor for terms in our new calculus. And so, the terms are parametric in a channel, a message, and a continuation, like a rholang receive, basically. Oh, yeah.
What will you get back when you call this contract?
Yeah, that's a good question. Yeah, maybe you get back like a name that represents that thing, and then it's the creator's responsibility to find it one to comm with, or something like that.
Mm. And how can you find a comm?
Yeah, one way I guess would be like if I just made two of them myself, then I know that I can. So I guess the idea is like, oh, maybe. Oh yeah, go ahead.
You're matching with the channel name. This is like what you're saying. This is a comm.
Yeah.
Oh,
that's the criteria. If they have the same channel name, then they should be able to swap the message with the receive one for the other.
But in a sense, can we use like a regular send receive? So you don't have to have a map. You just put it in a tuple space and.
Yeah, that seems like a good simpler idea. Yeah, so maybe we'll scratch that part, and then how might it look like?
Just to create a new pair of send receive. This is like exactly what you.
A pair of names. You're saying, right?
Yeah, the channel name is in between. No. I was thinking that you send on the channel name and receive on the channel name, and this will be a call. And this but well, not directly. Yeah, but this is not correct because.
It's almost like
But if we return channel name to the caller,
yeah,
he can send something, and we can receive it. No, but this is not what we want.
I think that the map that I was thinking of almost was going to be like a tuple space. So when we've talked about implementing rholang, the tuple space is interesting because it has two halves, right? There's the half that's all the sends and the half that's all the receives. And in this calculus, it wouldn't have two parts. It would just be a single piece, basically, right? From from channel names to
Oh,
you don't split out the sends and the receives anymore.
yeah.
Because the
Oh,
way
so you're saying like a map of pairs of send receives,
yeah,
right?
yeah. That's I think that is what I was thinking.
But
So, yeah.
then we must find a match like manually, right?
That's that's what I don't want to do. Yeah, exactly. I don't want to write a. Well, it devolved pretty quickly into writing a whole new interpreter in rholang.
Yeah. But this is interesting because do we have anything in between, or and I mean, you know, can we uh, use part of rholang and not write the whole thing, or we can
That's
just?
the goal. Yeah, that's the goal. Right.
But I'm not sure.
So yeah, we can. Um, we have to do a pattern match. Whenever somebody calls something in here, we're gonna do exactly this. We're gonna put a send and a receive. Uh, and we're gonna send. So we're already going to guarantee that they're on the same channel name simply by us doing the native rholang sends and receives on the same channel name. And
Yeah.
then we're going to send the message along. I don't know if this is making sense. Somehow they were going to have to authenticate one another. Yeah, that's right. So we're going to send the message and the authority secret. And I'm going to send it as the tuple. So the way that we guarantee that we won't get these receives or these sends, oh, it doesn't work for the sends, darn. I was going to say we can guarantee that these receives will not com with other random junk that happen to be sent on the same channel by ensuring that we always have this pattern. We're going to always receive the message and the exact same authority secret. So we've basically said, like, we only want to receive messages that have this item as the second item in the tuple. And the reason that that's valid is because the only sends that will ever have that are these sends that came from the contract, because the authority secret is only in scope there.
I have one question.
Yeah.
But someone can listen on the channel name. Can we send on the tuple channel name and the authority secret?
Bingo. That's exactly what we wanted to do. Yeah, good job.
Yeah, now this is starting to make sense. Yeah.
And then what do we need to send? Just the regular message?
Just a message.
Yeah, dude, perfect. Yeah, that's exactly right. Because now we've just tagged these channels as being specifically the kind of channels that these crisscross comms can happen on. Nice. Okay. So,
But you must send change the form, because you are receiving just a message.
oh yeah, I still need that. I don't think my parens are matched.
Yeah, and the arrow must be like before the tuples.
Oh, wait, sorry. This was
Yeah.
totally, I got myself confused. This is where we want the tuple, right?
Yeah.
Oh, whoops.
And you were using in your example, you were using par, but maybe tuple is better, right? Because you have position. I was thinking on your example, can you switch if you have more than two names?
Yeah.
You can like switch it, and if they are not unforgeable, then maybe some name is the same as the other one.
Oh,
I was just thinking that,
yeah. Oh, totally. Yeah, you're right. If they're not unforgeable, totally. Because you basically you have like multi-set semantics instead of list or tuple semantics.
yeah. So
Yeah. In the one
tuple maybe.
example that was necessary, I was using that as a feature because they were going to be in opposite orders and we wanted them to match. But I think here you're definitely
Oh, yeah.
because in the one it depended whether the mother or father constructed it, which order the genes were going to be in.
Yeah.
Yeah.
Yeah, cool.
But here that's not a problem and the tuples work fine, I think, right?
Yeah, exactly.
Okay.
This is what we want.
So we're almost there. We're getting super close. We just have to deal with these receives now. And we might have to do the trick that Stay mentioned where we extract the entry point.
And then you need one bracket here, closing.
Oh, yeah. Yeah, thanks. That looks better. Okay. So when we get one of these things coming along to have a COM event, we get a message in here, then somehow we have to, inside of this continuation, we have to pump that message along into the receive. But the receive is itself presumably going to be a 4, right? Because that's how the programmer or the person who's using this interface would specify what hole to use.
Oh, yeah.
Right, that's where this is also something that I was talking about with Mike that I think he.
So you now you want to match. You want to match a receive for 4, right?
Yeah.
Cool.
Like this is what you're thinking, right?
Yeah, exactly.
And otherwise, well, should we do that up here? Because otherwise people are going to call this with all kinds of weird things. We'll do that in a second.
Or we can put match as a first child of contract. Right.
Oh yeah. That's
this
right.
is the same, right?
That's right. Well, no, it's not. Well, yeah, it's
almost the same, right?
It's the same. For the caller that calls it wrong, it's not the same, but that's not really our problem. Right? If
why is not the same?
Wrong, they'll still get to hear, but then they'll hang because this. Well, we can just get here. No, it's totally solvable. We're going to take that and put it here. I think, or something, right? Am I getting close?
Yeah.
I don't know where that came from. Okay.
Oh, so you're saying we can acknowledge that this is error or something.
Yeah, exactly. You called the.
But we must send something to receive, or because if you have only something to standard output, you cannot check if this is like successful or
yeah,
not.
This is a totally crappy way to do it. We would just need to have another like.
But I'm thinking that what is the difference if we put directly matching for 4 inside argument, and if you don't match, what will be caller?
If we put it here where my cursor is now.
Yeah.
If we put it here and they call it wrong, then we just never get a COM event. Whatever wrong thing they sent sits in the tuple space.
But I'm thinking what will be for the caller? How the caller will know if this is matched or?
Oh yeah. Oh, good point. Oh yeah. In either case, it would just sit there and never COM.
But
Yeah,
So
so
if,
it really
if you
doesn't
want,
depend on the color.
if you want to send to caller that this is not something that is matched, you must have a match inside them.
You're right.
Then
Yeah, you're
cancel,
totally right.
right?
You're totally right. If we want to get back, if we want to give them feedback, it has to go this way.
Okay.
So should we could do something like this. I think the way Archer was doing it was like this. This is like their either and false is left.
Oh, I see. Yeah. Oh, so we can use it. Receive. No. Yeah.
Seem good?
Yeah.
Okay. Okay, cool. So now we have to finish this part though, and we decided not to do that. So the question is, what do we want to match? Some kind of 4. And then inside of the body, then we have to do something.
I remember that you want to extract listening channel.
Oh crap! I spilled that. Yeah. So let's look back. Oh, I thought that. That's my. I want to find Mike's. Yeah. Okay, so is this relevant?
Yeah, this is the example.
Here's what we're looking for, I'm pretty sure.
But I think you wrote some simpler, like a simpler example.
This is when I finally posted all the Adam and Eve stuff up here. I think that maybe was kind of the end of that.
Yeah, but in your response, I remember that you wrote some simpler example, or I remember that you wrote it in a different way.
Yeah.
But I don't remember.
Oh, yeah. This is actually the second phase of this conversation. So we did this at some point. So over P channel, we send this 4. That's basically what we're going to be doing here, right? We're sending a 4. And then up here, wait, where did I send that? Oh, yeah. We get P from P channel. Oh, the problem here was that we had to already know and share this name, this entry point name, right? So he was going to show us how to extract it. Oh, here. Let's go back up here.
Okay, I'm back.
What's that?
I'm back.
I didn't even know you left. I had our things minimized. I was just looking for the looking for the right comment that whole time.
Yeah. Okay, now I'm here.
Well, at least you weren't bored while I was looking. So I thought, oh man, okay. He did something with a constructor. Let me search for that. I'm pretty sure this, I think this is what we were looking for. I'm pretty sure. Yeah, okay. So I think I know what we can do here. And I can illustrate it by first doing it a janky way and then making it a better way. So I think we're done with all of this. And all of this can be commented. So, okay, here's our note. For now, always use some janky channel as the entry point. And then I think we can generalize this the way stated to make it better, but it's going to be easier for me to wrap my head around it this way. So I think we want to match the receive to for whatever they receive from at janky channel, then do whatever. It doesn't matter what. So what we've done is we've made sure that the user of our make, send, receive hybrid has called with the appropriate kind of receive, and the requirements of a receive are it has to have a for, it has to be a linear for, and it has to be listening on janky channel. And if it is, now that we've handled all of that stuff, then finally whoops, we can send message. Does that seem right?
Okay. So you're matching on junkie channel, and this will be like a comment, right? And you will have a message that you send on this channel. But
yeah, what was this?
Now my question is, why we need this for?
Wait,
we could receive. No, that we are matching.
This for.
Yeah.
That's not an actual for. That's the pattern we're matching against.
I'm wondering we can use only channel name, not the whole for. Right.
Say that one more time.
We can use just junkie channel to as a receive, not the for. Or
you mean like this?
Yeah, just the junkie channel. Yeah.
Well, this is not even a valid process. We have to write.
No. I mean just the junkie channel as a process, as a.
Like this?
Yeah.
Because this is going to be a whole like for process. It's not going to be, well, first of all, that's a name, but that's a process. Like they're not going to send what they send. So let's write here. That's actually a great question. So let's try this. And we never ended up using that map idea, luckily. So what if, let's imagine, I'm just going to encode our example real quick. So we would want to call make, send, receive, hybrid. And we would call it with for, and then, oh, well, first of all, we would have to call it with like we would have to do this, new test chan in, oh goodness, there we go. So we have to give them the com channel that we're going to test over, and that's going to be later actually replaced with that tuple of the test chan and the authority ID, but for now it's just test chan for. And then finally, the last thing that we're going to send is for, whatever it is, X from janky chan. This is our hack. It has to be this for now, but we'll fix that soon. And then we were going to standard out. What was it again? X is, oh yeah, there's not a great way to do that. Okay. This time we sent 5. We're calling that y, and we're saying y is y. So I think that's our test case. Oops.
Oh, I see.
I got to save that somewhere.
Okay, so you want to have a continuation.
Well, I'm open to that looking differently. That's what I was thinking so far, and the reason that that's nice is because then we can do this polyadic stuff. Whatever. All coming across. Well, what's the other way that it could look like actually, if not a continuation or a forward process?
What do you mean?
Is there so? Well, yeah. So we were talking about what receive would be and what we had to pattern match it against.
Yeah. Now I see. Yeah. We want to forward because we want to have this continuation.
Yeah, but now my question back at you, what basically I'm saying, like I had never really thought of trying it any other ways, but do you think there is a better way to try it than sending the whole 4?
Yeah, I'm not sure. This like a sound very, very nice.
Yeah,
right?
Okay, cool. I think it'll work then. So what did we call this though? Oh, underscore. We don't care what it is at that point. Oh no, not nil. Anything.
Yeah, and instead of a junkie chain, you can use whatever you want, right?
Yeah, for the inside of your thing, you mean? For your continuum. Yeah, totally. Including something with multiple variables if you want to. So it's only a little bit janky. Okay. Are we ready to run it?
Yeah, definitely. Do it.
I think I have a node running still from earlier. Yeah, that's internal communication. Well, it seems to be still running. All right, let's try it. Oops, our node eval. Now we get to go through the fun process of 1,000 forgotten pars and forgotten stars, forgotten apps. Oh, we're definitely not doing this because I'm never going to be able to see the actual error messages past all of the network chatter.
Oh, yeah.
I don't know how long we have to wait for that to come up. Wait, what? Oh, it wasn't done. Okay, it wasn't ready yet. But maybe now it's ready.
So in a sense, this 4 that we are sending is we are simulating this function. We are simulating function.
Yeah.
Because right in raw calculus, the difference between lambda calculus and raw calculus is just this separation of application.
Yeah.
And in a sense, we are putting this back again close together, right?
Application, you mean, right?
Yeah. Totally. Because you're sending, and when the receiver receives the message, you will automatically execute your continuation.
Yeah, that's right. Cool. Okay, I don't know what's going wrong here. It's not. Oh, and now I got a period. That's not what I wanted. I can't get the code to run for some reason. Oh, there we go.
Okay. Yeah.
Oh my goodness. Now we got to find oh, there it is. Okay, line 14, character 9. I wonder maybe I need these. Name variable message on line 11 used in process context on line 16. Free variable make, send, receive hybrid is used twice as a binder, 11 and 27. Make, send, receive. Wait, how does it get spelled again? EI? Free variable standard out. Grrr.
Oh.
This really should be incentivizing us to finish some of our alternate interpreters.
Yeah.
Receive at 14 and make, send, receive hybrid at 28. Didn't help that I picked a word that I hardly know how to spell. Okay, something.
Oh.
Did we get any output? Okay, there's the code. I don't see any output though.
We need some debugging output. Yeah.
Yep. Oh, I can't do that. Let's start with that. Now we got to find the error message. 19.
Oh,
I don't see any output still.
yeah.
So we never got to the contract? Okay, we got that.
Oh, okay.
Okay, so we got running main program, but we never got anything to com. Oh, because it's supposed to take a success channel. I blame you for that one, Thomas Love.
Oh, yeah.
JK. So we just need to send it. That's where we can send our error messages probably, right?
Yeah.
All right. Okay.
Oh.
Neither one of them matched.
Hmm.
So the pattern was for anything from Janky Chan, do anything. That's a little surprising.
Yeah.
Let's do a little, let's strip this down to the bare minimum. So, well, I'm just going to do this. New channel here. Oh, it doesn't even have to be that. It can even be easier than that. So we can do match for y from x do nil against, here's the first one for,
Oh, cool. I remember your question like a long time ago about matching 4.
yeah, I know, these same things keep coming back.
Yeah.
I'm pretty sure I even, wow, I already have a file called matchtest.row. I clearly have a lot of, a lot of matching problems.
But I was surprised what you wrote then, because I was expecting the same thing, but
Something
your question was
going on with that. I want to get this thing to be quiet. Okay, so first of all, let's see what my old match test was. Oh, dude, it's like literally the same thing. On X, I sent a 4, and then I pattern matched to this 4.
Yeah, but now we wrote the simpler case.
It's even simpler now, yeah.
Yeah,
That's right.
yeah.
I'm pretty sure that one worked, though.
Yeah, but this is like a good idea. You just write match inside the new. That's
yeah.
it.
Yeah.
And match is interesting because creates a pattern, and I mean creates something with the whole. Like it's a binary operation.
Yeah.
Right.
Yeah, definitely a binary operation.
Yep.
Yeah, totally.
I was thinking that how to create custom operators.
Oh, like overloading or something?
Yeah, and Mike was saying that they were thinking about like macros for this.
Oh yeah, hygienic macros. Yeah.
Yeah.
Yeah, that would be great.
But I'm thinking that in rholang we have reflection, and macros are really something that you need if you don't have reflection.
Oh, interesting.
Because you don't have a way to in your language write your language, so you have some kind of different way of generating code. But we already have a way to generate the code.
Reflection, code writing code.
Because now you are sending 4. This is like the example of reflection.
Yeah.
Because in JavaScript you also have reflection. You have a val and you can send a string and you have reflection. But
I didn't know that counted.
But yeah, but the problem is that you are sending strings. This is not the real code. You must do some kind of magic, and then this becomes code. So
yeah, right. Yeah, eval is the magic, right?
Yeah.
But we did not get a match here. Oh, wow. Look at this. It's saying match for x2 from x0. And the case was for anything from x2. That's not
But this is this the same x2? Oh, it is. No. No, x is not the same. This is not the same x, right?
I don't know.
In the first. No, this is two different x.
The way it interpreted was, this is the case, the match case for anything from x2. And it interpreted my first one as for x2 from x0. So it has the thing on the left of the arrow in the match being on the right of the arrow in the case. So it has the y being on the right of the arrow. That doesn't seem to make any sense.
Yeah.
Okay, let's look at this one real quick. I'm going to run it even. That totally worked. I wish I could see them both at the same time. Let me stand by.
I didn't see output.
Right. Oh, you're right. There's no output. I got confused with this.
Okay.
Thinking it was output, but it's not. Yeah, so you're right. That didn't match. Well, that's weird.
Do we see the log?
In this example, you're sending on X and receiving on X.
Yeah, this is what I'm sending. Yeah.
Yeah.
Okay. Well, now I want to see what I really thought I had this working in my tutorial. So let's check there. Oh, I forgot the code snippets don't show up in here. Damn it. I think this is it. Oh, I know. No, I never put it. It's not in there.
But
All right.
we can we can look at Mike's example on Discord,
Oh,
right?
okay. Yeah, that's right.
But it looks the same.
Oh shoot, sorry. My scrolling gets messed up sometimes. I don't know where we were just now, but it was higher than this, I think. Almost. Maybe this.
Yeah.
I mind if I look at the one above?
But yeah, this
What
is
were you going to say about that one?
this is only sending, right? I don't see match.
Yeah. Here's one though. So okay, on P channel he sends a for process, and then matches star P. Dude, that is like exactly. That seems like the same thing, right?
Yeah, totally.
For underscore from construct do underscore. And we had. I wonder if his works. Should we try his code?
Yeah, yeah. But there is no curly braces in the match. So
Yeah, around the for.
yeah,
Yeah. Well, let's see if it complains about that.
yeah.
Oops, not there.
But I think that Mike can write something like that from the head.
Yeah, it may be untested. Yeah. Four seven to 410. Yeah, so I'm
Yeah,
guessing that's we just probably need these, right?
yeah, yeah.
I don't think that's a huge deal. Whoops. Oh, name variable X used in process context, 35 and 36. Oh, well, what? I don't even know what we expected to happen there.
Yeah, but we expect calling standard output with x plus 1, right? And not only once, multiple times.
I need to, no, this is a join. We need to also send something on B channel.
Oh, yeah.
Wait, did anything happen?
Oh, no. But we still don't have any.
Yeah, I don't even see this in the code here though. I'm not sure I ran it correctly.
Why is that?
Make sure we know what we're looking at. Okay, yeah, so it definitely scrolled up.
Uh,
Oh, here it is. It's just, I guess, because it's par.
okay. Yeah,
Oh, yeah, so it did not match here either. So we're actually maybe having a pattern matching problem.
yeah.
Well, should we file an issue and call it a day?
Yeah.
All right. I'd be happy to write it up. That was fun.
Yeah, definitely very fun.
I think that could be a cool program too if we get it running.
Yeah.
Yeah. Nice. All right.
Are you going to have this rolling hours each Thursday after testing?
Yeah, Jim and I have been trying to. I will be the first to admit that I've been a little bit flaky recently, but I hope to. What are your thoughts, Jim?
I missed the question.
Are we going to do this every week?
Oh yeah. I'm gonna have to watch the video to catch the whole thing here as to what you guys did, because I was.
I'm leaving.
Yes, I'll be a second, huh?
Okay. Hello.
I just did this little program here to execute both. So we do it. We create a listing. We execute procedure P.
Oh.
If we get a message on the interaction that's returned, and if the interaction is called with procedure X, it does both P or X or neither one.
Oh, this seems like a pretty good idea.
Just a sort of a transaction.
Yeah, nice. Jim, can you throw that on Discord? I'm going to update the rholang wiki with all the snippets we wrote today and the link to the video and everything.
Okay,
Oh,
I
cool.
just want to test this again.
Yeah. Did it run? Did you test it?
I'm sorry?
Did it run?
No, I was just getting to the point of getting out the errors.
Oh, yeah. Oh, nice. Yeah.
So, but in principle, it'll work.
Yeah, totally.
I'm not
Sounds
sure.
like someone's waiting for you, though, right?
I'm sorry?
Sounds like someone's waiting for you.
Yeah. See you. Bye-bye.